For most of the space age, Mars has had a reputation. A cold, rusted, finished world. A planet that did all of its interesting geology billions of years ago and then simply switched off. No drifting continents, no erupting volcanoes, no magnetic field to speak of, just red dust and silence. That is the Mars most of us grew up with, and for a long time, the data seemed to agree. Then in April 2026, a team of scientists went back to the seismic recordings from a single NASA lander sitting on a flat plain near the Martian equator. Buried in that data was a signal that a truly dead planet has no way of producing. Something roughly 100 kilometers beneath the surface was behaving in a way that only one thing can explain. And if they are right, the idea that Mars is a dead planet is simply wrong. Welcome to another episode of SOU Discoveries. To understand why this finding matters, you first need the story we had already settled on. Billions of years ago, Mars was not quiet at all. Between roughly 3 and 4 billion years ago, it was one of the most volcanically active places in the solar system. It built Olympus Mons, the tallest volcano we know of anywhere, and a whole province of giant volcanoes around a swollen region of crust called Tharsis. But Mars is a small planet, only about half the width of Earth, and small planets cool quickly. A hot object bleeds its heat away through its surface, and the smaller it is, the faster the heat escapes. Mars had less heat to begin with and a lot of surface to lose it through. So the reasoning went like this. As the interior cooled, the slow churning that drives volcanoes and generates magnetic fields would gradually grind to a halt. Mars lost its global magnetic field around 4 billion years ago, which told scientists the engine deep inside had already turned off. The volcanoes fell silent, and for something like the last 3 billion years, the assumption was simple. Nothing much happens inside Mars anymore. That was the rule, and every textbook repeated it. So how do you check what is happening deep inside a planet you cannot cut open? You listen to it. When the ground cracks or shifts, or when a rock slams into the surface, it sends out seismic waves, which are just vibrations that travel through the body of the planet. Those waves come in 2 main types, and the difference between them turns out to be the key to this entire story. The first type, called P waves, push and pull the rock back and forth along their direction of travel, the way a sound wave moves through the air. The second type, called S waves, shake the rock sideways at right angles to the way they are moving. Here's the part that matters. S waves can only pass through solid material. When they hit liquid, they stop, because a liquid has nothing to shake sideways against. P waves, meanwhile, slow down in hot, soft rock and speed up in cold, stiff rock. So by measuring exactly how fast these waves arrive and how much they weaken along the way, you can map what the inside of a planet is made of without ever going there. This is how we discovered that Earth has a liquid outer core more than a century ago. And in 2018, NASA sent a lander called InSight to try the same trick on Mars. It set a single extraordinarily sensitive seismometer down on the surface and then waited for the planet to shake. It did not have to wait long. Over the next 4 years, InSight recorded more than 1,300 Marsquakes. Most were faint, and most traced back to a single scarred region near the equator called Cerberus Fossae, a place we will come back to. But on the 4th of May 2022, InSight caught something in a completely different league, a Monster Quake, officially cataloged as event S1222A, registering a magnitude of 4.7. It released 5 times more energy than any other seismic event ever recorded on another planet. While 4.7 quake is moderate on Earth, it is a massive, planet-shaking event for Mars. It caused the entire planet to vibrate and ring like a bell, sending out seismic signals that resonated for at least 6 to 10 hours. And strangely, it had not come from Cerberus Fossae, the region responsible for nearly all the other quakes. It came from somewhere else entirely, a stretch of ground with no obvious cracks or faults on the surface at all. So the question landed straight away: what could shake a supposedly dead planet this hard from a place that looked completely ordinary? Here's where it turns into a detective story. The fingerprint of this quake, the particular shape of its waves, looked a lot like 2 other large events InSight had recorded, and those 2 had a known cause. They were meteorite strikes, space rocks slamming into Mars hard enough to shake the whole planet and punch out fresh craters. So the natural first guess was that the Monster Quake was another impact. If it was, there would be proof waiting on the surface, a brand new crater, one expected to be around 300 meters or 1,000 feet across, with a blast zone stretching well over 100 kilometers or 60 miles. A crater that size is not subtle. It would be visible from orbit. So an international team pulled in spacecraft circling Mars from several different space agencies and began searching the region the quake had come from. They combed an area of roughly 144 million square kilometers. It expands almost as large as the dry land on Earth, hunting for a fresh scar, a new dust cloud, anything at all. After months of looking, they reported the result. Nothing. No crater, no blast zone, no impact. And that absence is the whole point. If a rock from space did not cause this quake, then the energy came from inside Mars, from stress buildup in the planet's own crust, suddenly releasing along a hidden fault, the same way earthquakes work here. Mars has no drifting plates like Earth does, which made a homegrown quake this large genuinely unexpected. The crust of Mars is not frozen and finished. It's still under strain, still shifting, still able to unleash a jolt this big. In the researchers' own words, the planet is far more seismically active than anyone had assumed. But a crackling crust was only the surface of this story. The strangest part was still waiting 100 kilometers down, and that stuck with me. The surface version, the one everyone agreed on, was never the whole story. You only got there by looking underneath. And that's true for the news we watch every day. Most of us only see a narrow slice of reality, shaped by the outlets we follow and where we live. And with science news, it's trickier still, because headlines get exaggerated or oversimplified to chase clicks. That's why I use Ground News, a platform that lets you compare how different outlets cover the same story, showing you political slant, headline framing, and even the stories you're missing entirely. For example, when NASA recorded lightning crackling on Mars for the first time, I wanted credible, unbiased coverage, and Ground News made it easy. That story was covered by 202 sources, and I could instantly see the bias distribution was almost perfectly even. Then check each outlet's factuality rating, verified by 3 independent media monitoring organizations. Fittingly, Ground News was founded by a former NASA engineer, so there's a strong foundation for trustworthy science coverage too. My favorite feature is the blind spot, which flags stories disproportionately covered by just one side of the spectrum, so you always know what your feed is leaving out. And if you only follow science, tech, or space, their interest pages cut the noise and show you only what matters. For viewers of this channel, there's a special offer, 40% off the Vantage plan. Scan the QR code on screen or head to ground.news/SOU, link in the description. Now, back to Mars. That quake told us the shell of Mars is alive, but it left a bigger question hanging. Is the planet still warm on the inside? Or is Mars just a crackling, shifting crust wrapped around a cold, dead core? In April 2026, a team went looking for the answer. And this is the freshest and maybe the strangest part of the whole story. They took the seismic waves recorded by InSight and traced them downward, past the crust and into the mantle, the deep layer of rock that sits underneath. They followed them into the same corner of Mars those faint, constant quakes trace back to, the ground around Cerberus Fossae. And about 70 to 100 kilometers down, the waves did something strange. They slowed sharply. Now remember what slowing waves mean. Waves lose speed when the rock they move through is hotter and softer. But this drop was too steep for merely warm rock. So the team worked backward to what could cause it. And only one answer fit. The rock down there is not fully solid anymore. Part of it has melted. In the hottest pockets, more than a tenth of it has turned to magma, molten rock, seeping through the solid material around it like water through a sponge. And something has to be keeping it that hot. That something is a plume, a tall column of hot rock that rises from inside the planet, drifting upward the way a blob climbs through a lava lamp. It pools beneath the crust and pushes its heat into the rock above, enough to melt it. Here's the part that makes it feel real. You do not need seismic waves to find this plume. It has left its mark right on the surface, where anyone with a good map of Mars can spot it. The whole region is bulging upward, lifting into a shallow dome. And scattered across that dome are old impact craters, the round scars left by ancient collisions, except their floors are no longer flat. They are tilted, and they all lean the same way, toward the middle of the bulge. Something lifted the ground beneath them long after they formed, and the only thing big enough to do it is the plume pressing up from below. If you want the whole picture at once, the study draws it as a simple slice through Mars, crust on top, a wide pocket of half-melted rock just beneath it, and under that, the plume, driving heat and pressure upward. So Mars is not only cracking on the surface. Deep down, in at least one place, it is still hot enough to melt rock, and it pushes hard enough to bend the ground above it. The quake showed us the outside is alive. This shows us the inside is too. So the dead planet story falls apart. The crust of Mars still moves, and the rock deep inside it is still hot enough to melt. Mars is not a frozen leftover, it's a working planet. And that alone is a real surprise. Because Mars is small planets are supposed to cool down fast and go quiet, the way a single cup of coffee goes cold long before a full pot does. Mars should have gone cold ages ago. It didn't. It is still running, billions of years past the point where it should have shut down. But here is why this reaches far beyond rocks and geology. Think about what heat actually makes possible. Life, at least the only kind we know, needs two things more than almost anything else. It needs a source of energy, and it needs liquid water. A warm interior hands you the first one. So the question becomes, what about the water? Remember, this is a planet whose surface is bone dry today. But in 2024, a different team dug back into the same InSight data, and they found something waiting under the ground. Not a lake, not an underground sea you could swim in. Water soaked into rock, roughly 11 to 20 kilometers down. The tiny cracks and pores inside the rock appear to be filled with liquid water, the way a sponge holds water without looking wet on the outside. And there's a staggering amount of it, enough if you could wring it all out and spread it over the planet to bear the entire surface under an ocean 1 to 2 kilometers deep. Now hold the two discoveries side by side, heat rising from below, water locked in the rock above it. Both of them on the same planet at the same time. up to the surface. Mars is freezing, dry, and raked by radiation the thin air cannot block. But go down far enough and you may find the two ingredients life leans on most sitting right next to each other. Let me be careful about what that does and does not mean. Nobody has found life on Mars. This is not that. What it means is smaller and still enormous. The deep underground of Mars is no longer an obvious dead end for the question of life. It is somewhere worth looking, and that is a very different Mars from the dusty, empty rock we thought we understood. InSight itself went silent in December 2022. Its solar panels slowly disappeared under Martian dust until there was not enough power left to keep listening. But the years of tremors it recorded are still being studied today, and every fresh look points the same way. The planet we wrote off as dead has a pulse of its own. Buried deep down, it turns out it always had one. We just had to learn how to listen to it. So thanks for watching, and thanks to Ground News for sponsoring this video. If you're tired of clickbait headlines and just want the real story, especially in science, scan this QR code or head to the link ground.news/SOU given in the description. You'll get 40% off the Vantage plan and finally see the news like you see the universe clearly.